Hey everyone, in this video we're going to learn how to perform operations with functions. Our first example, given the following table of values for the functions f of x and g of x, evaluate the following. In our table, the first row represents the inputs, or the x values. The second row are the outputs for the function f of x, and the third row are the outputs for the function g of x. Our first example is f of negative 2 plus g of 1. So essentially we want to evaluate each function and then add their outputs together. So f of negative 2, the output is 6. G of 1, so we go to x equals 1, down to the outputs for g of x, and we see the output is 4, and 6 plus 4 is equal to 10. Next, we have g of 0 minus f of 2, so we'll evaluate each function first and then find their difference. So if we input 0, go down to the row for g of x, the output is 2. F of 2, so input is 2, the output for f of x is negative 5. So this is equivalent to 2 plus 5, which is equal to 7. Next, we have f of 1 times g of 1. So f of 1, if our input is 1, the output for f of x is negative 2. G of 1, input of 1, the output would be 4. And we're going to multiply both of these outputs together. So we have negative 2 times 4, which is negative 8. 2 times f of negative 1 plus 4 times g of 2. So we're going to find each output, then we're going to multiply it by the coefficient, and then add the two products together. So we have 2 times f of negative 1. So if we input negative 1, the output of f of x is 4. Plus 4 times g of 2. Input of 2, the output for g of x is negative 3. Now we're going to multiply each term. So we have 8 minus 12, which is negative 4. Okay, so this is good practice with evaluating our functions. And then once we get our outputs, we're going to add, subtract, multiply. We're going to perform one of the 4 operations with those outputs. Given f of x equals 3x minus 1 and g of x equals negative x plus 4, evaluate the following. So now our functions are defined algebraically. So we're going to first evaluate g of 2 in order to find g of 2 plus 3 times f of negative 1. So g of 2. So our input is 2 into our function g of x. So it's going to be negative 2 plus 4. So that's negative 2 plus 4, which is equal to 2. Then we'll evaluate f of negative 1. So inputting negative 1 into our function f of x, we're substituting in negative 1 for x. So we would get negative 3 minus 1, which is negative 4. And now we can evaluate g of 2 plus 3 times f of negative 1. So I'll choose a different color. So g of 2 is 2 plus 3 times the output for f of negative 1, which is negative 4. So we have 2 minus 12, which is equal to negative 10. So the output of this expression is negative 10. Next, we have g of negative 4 quantity squared. So we'll start by evaluating g of negative 4. So that's negative, substitute negative 4 in for x, plus 4. So multiplying negative 1 by negative 4, we get positive 4 plus 4, which is equal to 8. So now we're going to take the output for g of negative 4, which is 8. That doesn't look like a good 8. We're going to take the output of 8 and we're going to square it. So 8 squared is 64. So the output here is equal to 64. Same two functions. Now evaluate f of x minus g of x. So what do we notice is different? Well, the biggest difference is we don't have numbers as inputs into the functions f of x and g of x. So here they want us to come up with an expression that's equivalent to f of x minus g of x in terms of x. So what we're going to do is we're going to substitute the function f of x in first. So f of x is equivalent to 3x minus 1. And then we're going to subtract from that expression the function g of x, which is equivalent to negative x plus 4. We're going to distribute the negative 1. So we have 3x minus 1 plus x minus 4. And we can drop the parentheses. Since we have addition, combining our like terms, we get 4x minus 5. So that means f of x minus g of x, the difference of our two functions, is equivalent to 4x minus 5. Next, they're asking us to find f of x times g of x. So what is the product of our two functions in terms of x? So again, we're going to replace f of x with the function 3x minus 1. We're going to replace g of x with negative x plus 4. And now we're multiplying two binomials together. So we're going to distribute. I'll use a different color. So we'll distribute the 3x first. So we have negative 3x squared plus 12x. And then we'll distribute the negative 1. So we'd have plus x minus 4. Combining our like terms, we have negative 3x squared plus 13x minus 4. So the product of our two functions is equal to negative 3x squared plus 13x minus 4. So these examples are nice because they're working in some of our old ideas. Right here, we're combining two polynomials. Right? Each of these functions is a polynomial, and we're subtracting those two. Here, we're multiplying two polynomials, and we're doing it with function notation. So we're combining a new concept with an old concept. Next, given f of x equals 2x plus 7 and g of x equals x squared minus 6x plus 10, evaluate the following. So we have two different functions. So 2 times g of 1 minus f of negative 5, we'll start by evaluating both g of 1 and f of negative 5. So g of 1, we're going to substitute 1 in for each x. So we have 1 squared minus 6 times 1 plus 10. So that's going to be equal to 1 minus 6 plus 10, which is equal to negative 5 plus 10, which is 5. Okay, so that's g of 1. F of negative 5, inputting negative 5 in for x. So we have 2 times negative 5 plus 7. So that's going to be negative 10 plus 7. So f of negative 5 equals negative 3. So now we're going to substitute in the outputs of 5 and negative 3 into our expression. So we have 2 times g of 1, the output was 5, minus f of negative 5, the output was negative 3. So that's going to give us 10 plus 3, which is 13. So this expression is equal to 13. Next, we have f of 0 quantity squared plus g of 3. So again, let's start by evaluating f of 0 and g of 3. So f of 0, we're going to input 0 for x. So 2 times 0 plus 7, that's going to be 0 plus 7, which is 7. G of 3, inputting 3 for each x, we have 3 squared minus 6 times 3 plus 10. That's going to be 9 minus 18 plus 10, which is positive 1. So now we know the outputs for f of 0 and g of 3, so we can substitute them into our expression. So f of 0 is 7. We're going to square that. Plus g of 3, which is 1. So we get 49 plus 1, which is equal to 50. So this expression is equivalent to 50. Same two functions, but now we're going to find algebraic expressions. So in terms of x. So starting off, we have f of x quantity squared. So we're going to substitute the function f of x into our brackets. So that's 2x plus 7. We're going to square that. Remember 2x plus 7 squared, I'll change it to parentheses. That's going to be 2x plus 7 multiplied with itself. So we can distribute. So I'll use the red marker. So we distribute 2x first. So we have 4x squared plus 14x. Then we'll distribute the 7 plus 14x plus 49. Combining our like terms, we have 4x squared plus 28x plus 49. So f of x quantity squared is equivalent to 4x squared plus 28x plus 49. Then we have f of x minus 2 times g of x. So substituting f of x, we have 2x plus 7 minus 2 times the function g of x, which is x squared minus 6x plus 10. We can start by distributing the negative 2 into our trinomial. So we have 2x plus 7 plus negative 2x squared plus 12x minus 20. Now we have addition, so we can drop the parentheses. So 2x plus 7 plus negative 2x squared plus 12x minus 20. Combining our like terms, so we have negative 2x squared plus 14x minus 13. So the expression f of x minus 2 times g of x is equivalent to negative 2x squared plus 14x minus 13. Our last example, given f of x equals 4x plus 11 and g of x equals negative 2x minus 7, determine the value of x that makes the equation below true. And the equation they've given us is f of x equals g of x. So essentially what they're asking us to find is the input that makes the output of both of these functions equivalent. Right, so what input do they have the same output? So we can find this by substituting in for our function f of x and g of x and solving. F of x is equivalent to 4x plus 11. G of x is equivalent to negative 2x minus 7. And we have a function in terms of x that we can solve. We can add 2x to both sides of our equation. That will give us 6x plus 11 equals negative 7. We can subtract 11 from both sides. 6x equals negative 18. And to isolate x, we can divide both sides by 6. And we will get x equals negative 3. So if we input negative 3 into either f of x and g of x, we will get the same output. Now let's confirm that that's true. Practice evaluating functions. So let's evaluate f of negative 3. So if our input's negative 3, we're going to substitute negative 3 in for x. So 4 times negative 3 plus 11. So f of negative 3 is equal to negative 12 plus 11. F of negative 3 equals negative 1. Now we'll evaluate g of negative 3. So substituting negative 3 in for x again. Negative 2 times negative 3 minus 7. G of negative 3 is 6 minus 7. So g of negative 3 equals negative 1. So we've confirmed that if we input negative 3, we get the same output in both f of x and g of x. Essentially, what we were finding is the x value of the point where these two functions intersect. Negative 1 is the y value, but they were not asking for that in the question. So this video combines our function notation and evaluating functions with some concepts from previous units, such as adding and subtracting polynomials, as well as multiplying or squaring polynomials. Now it's your turn to go and practice so that you feel confident with your function notation and evaluating functions combined with all of the operations. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.